nowadays the presentations on Blackboard, so you can have access to it if you log in. You have your iPad, so that you can be able to just follow with me on your iPad. Let me go through the syllabus first. So my office has moved to HS, this building, 6th floor. It's room 613.
Okay.
My phone number is extension 1063. My email is, I think you know it, so in case it's on the syllabus. So if in case you need to communicate with me, email is fine. For office hours, I prefer by appointment. I don't want to set an hour that may not be available to everyone. Otherwise, it will be the common hours when everyone is available. But other than the common hours, email me and we'll make an appointment and I will talk to you and address your request or your concern. So, course description. What do you know about pharmacogenomics? Nothing? And that's fine. Anybody? Why are you here today?
To see you.
Why did you come back, by the way?
To see you.
Well, you have to address 3 questions for yourself this semester, just this semester, right? What do you want this semester, right? How you want it, and how you have to achieve it. So why you're here? Why are you here today? Or why did you come back for this semester? Because you may not even show up next semester or this semester, right? So why are you here today? It's very important that you tell me why you're here today and this semester.
To finish my degree.
To finish what?
My degree.
40 degrees. So, but today, that's a long-term, goal. In next year, you're almost there. But today and this semester, you want to complete the P5 semester, right?
Yes.
You want to complete it successfully. You want to earn good grades, and some of you may be going to residency, fellowship, or whatever. So you have different objectives in mind. For my course, you are here to learn pharmacogenomics. I don't want you to be here wasting your time. I don't want to waste my time as well. But it will help you to know what is pharmacogenomics and why it's important and why we have it in the curriculum, right? So, how are you going to complete, this semester? Or how are you going to earn good grades? I mean, study, right? Study. If you work, and if you need more time, then you have to cut on your working hours, and you just have to study and push yourself to do well. Okay, so let's move on. What is pharmacogenomics, and why do you have to know, and why do you have to study? Okay, so I'm going to go through the syllabus, and then I will give you some time to think, and then we'll come back to the why. So I'm not gonna waste your time because you can read all of this. I'm gonna go straight to the assessment because everyone here is concerned about assessment. So the way the course will be delivered is lectures. I will be asking you a lot of questions, and I hope that you will engage in discussions. It will be 1 midterm and 1 final and 2 quizzes. I have not decided yet whether the quizzes will be in class or take-home quizzes. I will make my decision as we move along. But the dates for the quizzes and the midterm are already on the course outline. And the quizzes will be administered a week before your midterm and a week before your final. It's a way to help you, understand and study and to guide your way to study for the midterm and the final. So the way the course is going to be delivered is, first of all, I know you have covered molecular biology, I know you have covered genetics, so I will refresh your memories about some concepts, basic concepts that you have already covered, but I want to make sure that you remember them. Then we're going to move to what is pharmacogenomics. Today is going to be an introduction and basic concepts of molecular biology and genetics. Then we're going to move to the pharmacogenomics and its application to several clinical situational diseases. And then we're gonna conclude with ethics and issues, associated with the application of pharmacogenomics to practice. And that's gonna be it. And that will be the end of the semester. And hopefully everyone will be just, passing the course. We don't want to go through remediation, right? Okay, great. So if you are, or if you cannot, or if you have some, a situation that you cannot make up the final or the midterm, of course you have to have a valid excuse. You have to inform me ahead of time. Don't come to me after the midterm or final. Sometimes it will be too late, I cannot do anything, but come to me before the final and the midterm. I think that's going to be it. And of course, I'm not going to talk about cheating because I believe you will not be cheating. So I have confidence that you're a professional student, and I don't have to worry about it. Okay, so now I would like you to start by reading this case. This is, by the way, I'm going to be using a textbook that is not on Access Pharmacy. I don't have to buy it, but for me, it's, if you want to buy it, that's fine, but I'm not going to require you to buy it, so I'm not going to assign you readings from the textbook. But I use it because it is better structured, in terms of pharmacogenomics. But I will refer you to the textbook that is on Access Pharmacy to do some reading or to, discuss cases. So I would like you to start by reading this case. Can you guys see it?
No.
So, can you guys log into Access Pharmacy? Huh? Read it for you. Okay, this is a recent grad at a local school of pharmacy and works at the only pharmacy in town. His name is JT. He staffs the pharmacy alone on Tuesdays and receives a call from Dr. Anderson, who is worried about a patient whom he had prescribed Pavix last week following a recent myocardial infarction. Dr. Anderson explains he has just learned that U.S. Food and Drug Administration has added a black box warning to the Pavix label to advise physicians of the importance of genetics and the availability of testing. Dr. Anderson wants JT to take immediate steps to make sure that Pavix is the right drug for this patient who is now on his way over to the pharmacy to have the appropriate genetic test done. Several thoughts run through JT's mind, and he quickly identifies a number of questions he must answer before the patient arrives. So some of his thoughts for genotyping are as follows. So what do you think about the case? If you are in this situation, what would you do? How would you counsel the patient on genetic testing? So some of the questions or thoughts that JT had was, is there any confidentiality or legal issue that he should be aware of before obtaining genetic testing? Can he share the results with others? What do you think? No. Do you know why no? HIPAA? Okay. Yeah, valid answer. Are there any liability issues if I don't do the genetic testing? Yes. Okay. Someone says yes. How accurate is this test? Do you know anything about the test? So if you are at the pharmacy today and the doctor sends you a patient that requires a genetic testing and is asking you if the patient is on the right drug and if the patient needs to take genetic testing or to have the patient take genetic testing before, put the patient on the drug, what would be your answer and what would be your approach? What is the question that will come the first time in your mind? What's going to be in your mind? sponsoring the patient taking genetic test? Do you know how to do it? Say it again if he needs to take it. It's a good question, but I didn't hear most of it. For? Yes, but this is genetic test. This is not any test, right? You don't withdraw blood for, you may withdraw blood, but that's different.
You have to withdraw blood.
It's not convincing the patient. What do you need to know? A physician is sending a patient to you, and the physician himself may not be sure if the patient needs genetic testing. He relies on the pharmacist that is an expert in drug to help him out. So how would you help the physician, and how would you make sure that this patient is taking the right drug, but before taking the drug, that the patient is being tested? Why do you think the patients need to be tested? Yes. That is correct. In case you have not heard your classmate answer, it says that the FDA has updated the label with black box warning, right? That products requires genetic testing, right? So by default, you have to make sure that the patient is being genetically tested, right? So now, how? How would you, yes? Yes, that is correct. Are you well equipped in the pharmacy to administer a genetic test? Okay. Do you have the box in the pharmacy? Do you have genetic tests? I'm asking all of you that are working in the pharmacy. Have you seen a genetic test? Which ones? Well, 23andMe is a company, but in the pharmacy, I'm sure several of you are, working in the pharmacy. Did you come across a genetic test that is available at the pharmacy? Yes.
No.
I just come across people who don't want to pay the cost.
Okay, so it's not in the pharmacy, right? Yes. Someone raised his hand. Yes. Paternal test? Paternal? Yes. But remember, the difference between paternal test and this is a test for a drug, right? Paternal test is mainly for genetic counselors and others. But this is everything that is related to drugs will become the responsibility of a pharmacist, right? So I think now you get where I want to go and the importance of you being informed and knowing about genetic tests. Not all of them, not hereditary tests. I'm talking about tests that are related to drug, outcomes, I would say. Okay, so let's go through the rest of the. So he was thinking about how accurate is this test? How clinically significant is this genetic effect? Penetrance. Do you know what is penetrance? Do you know what is penetrance? Yes? No? Yes? Okay, so I don't have to explain it, right? But I will explain it later. How to interpret the genetic results? Would you be able to do it? Assuming the patient took, took the test and he came to your pharmacy with the test results, relying on you now to tell him how he has to take the medication. Would you be able to do it? Reading the test, can you read the genetic test result? Yes? No? Okay, that's great, because this is why we have this course, right? This is what we have included pharmacogenomics in the program. So this patient has a lot of other drugs. So how does the person's genetics influence his or her susceptibility for drug interaction? So you cannot only worry about the drug that requires genetic testing, but also about all the other drugs that the patient is taking, right? Drug interaction. As of today, I know you have covered, drug interactions and side effects that may happen because of drug interactions. And then, he was thinking, what type of sample? How would he recommend to this patient to take genetic tests? Is it even possible to collect a sample for genotype at a pharmacy? How quickly must he collect the sample? And why do these requests always come to his? So you always say, okay, oh my goodness, why I'm getting into this trouble? Why this happens to me? Yeah, it happens to you because you are in the pharmacy and you have to address patients' requests. So the message that I want to just relay to all of you is pharmacogenomics is very important and will be even more important in the future. Why? Because a couple of years ago, the healthcare system has shifted from one size fits all to personalized medicine. So moving forward, patients will come to you at the pharmacy, whether you are in a community pharmacy or hospital or any other setting. And then you have to think about your patient as an individual and what's going to benefit this patient. You want to make sure that the drug will be effective and the drug will have less or no side effects for your patient, taking into consideration that the patient may be taking one or more drugs. So drug interactions is very important. So I'm gonna move now to my presentation. Okay, so does it make sense? So does it make sense now why you need to learn and why you have to be exposed to pharmacogenomics? Yes? No? It's not an easy subject, by the way. It's one, if you think, I think you're covering pharmacogenetics this semester, right? Right. So, pharmacogenetics in all students is, difficult, but pharmacogenomics can be almost difficult because it includes pharmacology, pharmacodynamics, pharmacogenetics, human or molecular biology, genetics, and therapeutics, and then you have to put everything together, to understand and address patients' request or clinical situations. But I'm gonna try to make it simple and easy for you because I would like you to leave with some, what I would say, relevant information, but important information that I would like you to remember, for years to come and build on it. You cannot just stop the way you think. So learning objectives. I'm going to go over the future role of pharmacists in pharmacogenomics. You will be able to identify challenges to the application of pharmacogenomics in clinical practice. And then we're going to go to the video at concepts, and genetics, polymorphism. I know we'll give you some website that you can check. Most likely I'm going to ask you, give the assignment. We will have the time, to look at them, and when we come back, every time we'll have discussions. So, based on this case, right, I'm sure you have identified key issues. If you are about to counsel your patient about genetic tests, right, so what do you need to know? And I just summarized them, briefly on this slide. So the key issue is the education, right? You have to be educated about pharmacogenomics, about genetic testing, and about how you can apply it. Because just knowing it is not enough. You have to know how to apply it in clinical practice. So it all starts with molecular biology and genetics that we already covered. Now we're going to move to application. So how about its application in practice? You need to know how to read the genetic test and how to interpret the genetic test. And I believe that as of today, you have already, come across a situation where there is no black and white, it's gray. So genetic test is still somehow gray area, but it will require your education, your understanding of the science, and then how you will interpret the test with some, or I would say, it has to be with certain accuracy. What are the barriers that are standing in the way of its application to clinical practice? Number one barrier is healthcare professional education in pharmacogenomics. And the second important issue is privacy. You know why? Because you take genetic tests, not only you reveal your DNA information, you also reveal your family, and sometimes extended family. So not only you may need your consent, but you may also need your other family members' consent. So this is the debate that has been an ongoing debate for a long time about the consent for patients and about the consent for other family members in case you find out that someone is genetic tested, may be exposed, or may be susceptible to develop certain diseases in the future. And this is a paper that I've published a long time ago in 2012. It's about pharmacogenomics, assessing educational exposure, confidential knowledge, and training elements for pharmacists. So the reference is there if you want to go and take a look at the paper. Okay, so now, what's in it for you? And why do I have to bother you every Tuesday morning from 1 to 11 to come and listen to me? And sometimes it may be boring, but I'm going to try to make it not so boring. So why? Because as a pharmacist, you will have to educate the physicians, the other healthcare professionals, the patients, the public, and so on. So people may come to you because you are the expert in drugs, and pharmacogenomics is drug related, so they will come to you. You're going to be the number one to explain and to address, patient issues. Talk about educating and counseling patients, such as possible interpretation of pharmacogenomics test results, selection of medication. If the result shows that the patient cannot be put on drug one, you have to have an alternative drug. And dosing decisions based on the genetic test, you will have to adjust the dose to your patient. Am I going too fast? No. So how you can influence the formulary? You will be able, based on the genetic information that is now included in the label or in the packaging information or prescribing information. Based on that information, you will be able to make recommendations on the drug that has to be included, on the list. But you will only be able to convince and recommend if you understand the information. So you do have to understand the genetic testing and genetic information that you will be reading on the label. Research, you can also influence research, whether you are in community pharmacy or in hospital or in any other setting. You will be able to do research, whether it's going to be basic research or clinical research or any other or social research. So you will have opportunities to engage in several research areas based on your information. If you want to stay active, want to contribute to moving forward, personalized medicine. So everything here is to move forward the personalized medicine, giving the right drug at the right patient at the right time at the right dose. So this is the objective of every single pharmacist, for the future. Okay, community pharmacists, opportunities for you as a pharmacist in a community, right? It's not well identified, well established today where patients will be going to take a genetic test. but there is a lot of talks that it may be at the pharmacy level, maybe at the community pharmacy, that the patients will come and get the genetic test. It will become, point of care, similar to the other, tests that the patients come, to the pharmacy for. It can, in clinical or in hospitals, the pharmacist can actually establish a clinical, or clinics for such coagulation clinics. And this is all under the responsibility of a pharmacist. So you will be the ones who will be in charge of pharmacogenomics in the future. At least, every single, indication is pointing to the pharmacist to take over pharmacogenomics and genetic testing. But let's see whether, this is going to materialize in the future, but apparently it looks like this is, because it's drug-related and you are more knowledgeable about drug than anybody else, so it may be coming your way. Okay, so what have we talked about so far? So are you convinced that pharmacogenomics is important in your education and you really should understand it and know something about it? Yes? No? Because I'm going to tell you something. When we started talking about pharmacogenomics, a lot of pharmacists had to push. They didn't like it. They didn't want it because they felt, well, I am not equipped. I am not knowledgeable about the science. It's too complicated, right? Things has changed. But we will keep surveying pharmacists nationwide, and it's not only in the US, it's worldwide actually. And we will keep surveying their knowledge, how comfortable they are in administering the genetic testing, interpreting the test, and making a recommendation on therapies related to drugs. So what do you need to know, right? You need to know the definitions and the terminology so that we all agree on the same definitions. So when you hear pharmacogenomics and pharmacogenetics, and a lot of people are using them interchangeably, so what do you think? Do you think it's the same? Do you think is there any difference? Do you care? I see you talking to each other, but talk to me. See, he was listening. The question is, what is the difference between pharmacogenomics and pharmacogenetics? I know it says on the side. I want to hear it from you, right? Well, this is what's going to help you on the test. You're going to remember that I asked you, and then you told me someone will remember it was on the slide, and then it will ring the bell, so you will remember the definition, right? So, pharmacogenomics equals pharmacology and genomics, right? So, but the difference between pharmacogenetics and pharmacogenomics, when we talk about pharmacogenomics, is it's in relation to one gene at a time. When we talk about pharmacogenomics, is in relation to several genes that are involved, at the time. Can you give me an example of pharmacogenetics and an example of pharmacogenomics? Okay. Yes, one gene. What is pharmacokinetics?
What? The hell is going on?
What is pharmacodynamics? So when you take a drug, right? What happened to your body? What happened to the drug in your body? Huh? It's gonna go through the ADME process, right? And it will have to bind somewhere to what? To a receptor. What is a receptor? It's a protein. Where is the protein coming from? A gene. So we're talking about a gene, about a receptor, but we're also talking about pharmacokinetics, right? The drug is metabolized by what? By enzymes. And enzymes are coming from where? From genes. So one example of pharmacogenetics, if the drug is only influenced by one gene, for example, one drug metabolizing enzyme. But when you talk about pharmacogenomics, if the drug dose or clinical outcomes is influenced by a genetic information that is related to both drug metabolizing enzyme and the receptor. So pharmacogenetics is in relation to one gene, pharmacogenomics is in relation to more than one gene, right? So, yes? The example, and we're gonna go through several examples, but just for today's purpose in general, is pharmacogenetics is in relation to a gene. For example, we have a drug that is metabolized by CYP2D6, right? Some patients may have genetic variation in CYP2D6. So for this patient, we're talking about pharmacogenetics because we are only looking at one gene, variation in one gene. If we talk about pharmacogenomics, then we're talking about the drug being metabolized by a gene that is polymorphic, which has genetic variation, and by a receptor to which the drug will bind that is also polymorphic. So now we're talking about pharmacogenomics. So the drug response is influenced by more than one gene. Bottom line, pharmacogenomics is a combination of pharmacology and genomics, and it uses patients' genotype to optimize drug therapy and minimize drug toxicity. So, to just, yes? It depends. To keep it simple, let's think about a receptor is one gene, for today's purpose. Because it depends on the receptor. Some receptors I made of 2 different proteins or 3 different proteins. But for now, let's just keep the thinking simple, and then we're gonna, address a lot of examples in the future. So the bottom line, you are using pharmacogenomics to improve patients' drug response. You want to make sure that the drug is the right drug, the most effective drug for the patient, right? So it has to be effective, and the drug will cause no or less significant side effects or damages for the patients. So the objective is to make sure that you're giving the right drug to the patient. You're optimizing, you are using pharmacogenomics to actually deliver individualized or personalized medicine to your patients. Okay, does it make sense?
Yes.
Okay. So let's talk about how all this started and why do you have to deal with it, right? So it all started in 2003, and I'm not going to ask you about the dates. It's just you have to understand, where the genetic testing and the pharmacogenomics are. It all started when the genome sequence has been completed of the full human DNA sequence has been completed. So meaning we know what's in our DNA and we know the information. So if you know the information, then you have to use it, right? You just don't want to do it, but you have to put it to a good use. You have to put it to benefit, the population and patients. So it did cost it did cost $2.7 billion and 13 years to sequence one human genome. That was a lot of money because for it to be sequenced the first time, it was a collaboration between different countries, different research labs and centers to come up with that first human, DNA sequencing. Today, you can sequence a full genome for less than $1,000, right? And it may take 1 day. So see the difference between 2003 and 2018? It's a lot cheaper, and it can be done quickly. That's why people have advanced personalized medicine, because if you can sequence a gene, and we're talking about full genome, we're not talking just about a small gene. So it can be done during 1 day, and this is a full genome for $1,000, meaning for smaller gene it can be less, and most likely because company in the future will cover not today, not for everything, not for all genes, but just for some of them. So the development of technology will bring the equipment of the genetic testing equipment to the physician's office and to the pharmacies. So they used to have large equipment to do genetic testing and sequencing. Now you can have a smaller equipment, and it's already tested and available in a physician's office. And some pharmacies, I haven't heard in the US, but in Sweden and in other countries, that are testing the prototype for genetic testing. So before you leave the physician's office, you may either do tests in the physician's office, so the drug will be prescribed at the right time, or you may be sent to the pharmacist to do genetic testing, and then the drug will be prescribed based on the genetic tests. So a lot of questions need to be addressed, and decisions will be made on how this, how its implementation, will unfold in the future. The good news is, for example, when you go for your yearly checkup, you always have to go for blood tests, right? And you have to do it every 6 months or every year, depending on the results. For the genetic tests, if you are going for genetic testing for CYP2D6, for example, you will only do it once in your whole life. So you can enroll your genetic variation or information one time, and it's good for life. You don't have to do it again, and it's good for every single drug that is metabolized by CYP2D6. So you may take it for one drug, but it also gives information about all the other drugs that you may be taking in the future. The key is it has to be stored in your electronic medical records, so that it will be available anywhere you go. It will be available to healthcare providers or professionals, to decide on, the right drug. So the genetic testing or sequencing took place in a lab, but after that took place, then the FDA has to react. Based on the information, the FDA has offered incentives to pharma companies to actually include genetic information in drug development. And in exchange, they will expedite the review of, the clinical trials. So that was good incentive for companies, so they started including genetic testing whenever they conduct clinical trial. They have included genetic testing for patients, for volunteers, and for patients in the review. The FDA has also required for drug companies to include, whenever available, genetic information, on the label or in the label about the drug or about, the enzyme. So if you look at, labels, you will find that there is always a genetic information whenever available. When I say whenever available, meaning we know about it, it has been discovered. So we have discovered some variations, but not all of them yet. So what we do is, what do we know so far? We have to include it if it has a significant impact on drug response. Any questions? Okay. So genetic test led to an FDA recommendations, but it also has pushed colleges of pharmacists and medical schools and nursing schools to include pharmacogenomics in their curriculum. So if you take a look at the curriculum for medical students, pharmacy students, nursing students, and other healthcare providers, you're going to see that everyone has included molecular biology, genetics, and pharmacogenomics in their curriculum. So, and why? Because at the end, you will have to communicate with each other, right? So you have to know the same language, you have to know the same definition, you have to be exposed to the same information. So you don't want to be exposed, you don't want to have a discussion with a physician that knows about pharmacogenomics, but you don't know anything. That you cannot engage in discussion. Then you're gonna feel that, oh, I'm not up to that level. So that's why everyone has to be informed and has to be educated about pharmacogenomics. Accreditation standards have also changed and have included the genetics, genomics, and pharmacogenomics in the standard, and colleges, they have to meet the standards. So that's why, again, you are in this class today to learn about pharmacogenomics. Okay. So I'm going to go over 2 slides. I'm going to need to go take a few minutes. So why? Why is it important? If you think about the diseases or conditions, medical conditions, you see that diseases are caused or are the results of our genes, right? But our genes alone are not the only, factors. It's the interaction with the environment, where you live, what you eat, how your body expresses the genes, and how they interact with the environment. That is going to result in either good health, or someone has a condition that may be either chronic or may require some sort of, therapies or drugs. So the bottom line is, as of today, we cannot change our genes. And I'm saying as of today because we may be able in the future, right? You hear, about in the news that some scientists have cloned some people who are rich and wealthy. They can create the best babies, the best looking babies, the smartest individuals. Because now there is technology, you can just go into genetic DNA and switch or change gene with another, right? So that's why I say as of today we cannot change our genes, and it's not ethical to go and try, to change our DNA. So it is fine, and everyone agrees that it's fine for clinical purposes, to cure diseases, to provide quality of life. But it's not fine just because you want to change something in your body that you don't like. So the genomics and this genetic screening will help make recommendations for more frequent screening, for genetic testing, and modified drug recommendation. So we want to use our genetic information to provide, better health care, to provide, patients with, quality of life and with the right drug or the right therapies. You can also modify exposure if you know your genetic susceptibility to to a pollutant or to environment. So you can limit your exposure, especially for people working in farms. You can change behavior if you know your susceptibility to alcohol or to smoking, because you are proactive. You will know in the future, what works and what doesn't work for you. So this is how genetic testing and genomics should be utilized. Is for one reason is to improve, curing or to improve treating the symptoms or to provide better quality of life for the patient and population. Okay. So do you have any questions before you guys go for breaks? Okay, so you can take 5-10 minutes break and come back, or if you want to continue wherever you want to just